So, we all know that the solar system has planets, right? The solar system is made up of the sun, the planets, and all the other things under the sun's gravitational influence. However, nobody can actually quite agree which of those things are really planets or not. The main point of contention is Pluto. Most people agree that Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune are planets. Pluto is very different from these planets, so it logically follows that it's not a planet. However, there are some people who learned that Pluto was a planet, given it was only reclassified as a dwarf planet relatively recently, so they still think Pluto is a planet. Given that the whole Pluto debate is quite stale, and that the arguments these people use usually aren't very good, this video is not about the Pluto debate. It's more about the concept of a planet altogether, and my opinions on what planet should mean to begin with. So let's start off with what the IAU thinks is a planet. The IAU is the organization in charge of naming things in the solar system. And given planets are named very different things than non-planets, it makes sense that they would have some authority as to what counts as a planet. The first criteria for being a planet is that an object needs to orbit the sun. This rules out moons, hyperbolic comets, and small ring particles from being considered planets. The second criteria is that they need to be round, but not just round, a specific kind of round called hydrostatic equilibrium, which basically means that they have enough gravity to force them into a round shape. This rules out, well, anything that isn't in hydrostatic equilibrium, which is primarily asteroids, but also some other things. The third criteria is that an object needs to have cleared the neighborhood around its orbit to be considered a planet. Now, there are a lot of ways you can interpret this, some of which disqualify a lot of things, and some of which disqualify only a few things. For example, Mars and Earth aren't planets because there's an entire class of asteroids called near-Earth asteroids, and if there are near-Earth asteroids there are definitely near-Mars asteroids as well. Objects in the asteroid belt or Kuiper belt haven't cleared their neighborhood for reasons that I hope are obvious for you, and Neptune can be eliminated using similar logic to Earth and Mars from before, where there are Kuiper belt object orbits that cross Neptune's orbit. Any object with Trojans can be eliminated as well, since Trojans are pretty much defined as being in the same orbit as a larger object. This leaves the solar system with one planet, Saturn. And you could even argue that if Jupiter and the Sun are a binary system, then Saturn isn't orbiting the Sun, it's orbiting the Jupiter-Sun binary system. So Saturn's not a planet because it doesn't orbit the Sun. So we can conclude that there are 0 planets in the solar system. We are using a very strict reading of the definition of planet, though. Usually people relax the rules quite a bit to allow all 8 of the traditional planets I mentioned at the start to be considered planets. But there's never really any specification as to how much relaxing they're doing. Because if you relax the rules too much, Ceres is a planet because it makes up almost half of the mass of the asteroid belt. So the correct amount of relaxing is the amount that makes the 8 traditional planets planets and nothing else, which I don't think makes for a very good definition. I do feel like it is clear what people are trying to get at with this definition though, which is this general separation of solar system objects into things that largely orbit by themselves, things that share their orbital region with similar things, and things that orbit other things. So here's my definition of planets and their subcategories based on the generalization of this structure I've noticed outside the solar system. As in, there will be no definitions that are specific to the layout of our solar system. But first, we should probably figure out what an orbital region is to begin with. I personally define it based on objects having a very similar semi-major axis, as in, objects are in the same orbital region if they are about the same distance from the star on average. But before we get into that, let's talk about which objects are planets as a whole. As we saw before, hydrostatic equilibrium doesn't do a very good job, since it disqualifies a lot of things you would expect to be planets, like Mercury and Venus. So I am going to have to just draw a line somewhere, and I've decided that a non-stellar object is a planet if it is more massive than 4e20 kilograms. This is about half the mass of Ceres. It doesn't matter how it formed or what it's orbiting, if it's more than that size, it's a planet. Anything smaller than that is an asteroid. Some people like to be annoying and say that asteroid only refers to asteroids in the inner solar system, and that the correct term is minor planet, but I'm not calling something a planet that isn't a planet, so those people will just have to deal with me using asteroid for that purpose instead. A planet that's orbiting something that's not a stellar object or stellar objects is a satellite planet. This refers to major moons like Ganymede, Titan, Ariel, Umbriel, those sort. If a planet is not a satellite planet and is not in a stellar object's gravitational influence, it is a rogue planet. And if a planet is in a stellar object's gravitational influence but is not a satellite planet, then it can be one of two things. If the object and any of its moons make up most of the mass in its orbital region, then it's an uber planet. If not, it's an interplanet. This means uber planets correspond to traditional planets, and interplanets correspond to dwarf planets. So, in conclusion, there are 37 planets in the solar system, and infinitely many outside of it. Okay, let's backtrack a bit. What counts as an orbital region? I mean, like, it should be obvious, just given the way systems form, where interplanets are found in distinct belts. And in general, I would classify any edge cases just as uber planets, given the exact boundary of an orbital region is something I haven't actually figured out. So yes, if you have that criticism of my system, then you are completely right. But I personally haven't had a hard time telling what's an uber planet and what's an interplanet. I do want to say that I at least define most in this situation to be at least 3/4. So at least there's that. I made this planet definition because I didn't like that the one that is in common use focuses more on the object's orbit than on its actual physical characteristics. Like, I'm pretty sure these are supposed to be, classifications of things, not of ways things can move around. Like, if you want to classify the ways things move around, that's fine, but I feel like it's going to be more important to know what things are themselves rather than how they move around other things. Another common criticism I see of a very extended planet definitions like this is that it's way too many planets to memorize. In that case, don't memorize them. Just memorize the uber planets and learn about some of the more interesting satellite planets and interplanets. Just like how nobody memorizes all 50 state capitals, except huge geography nerds. And anyone who comes up with the criticism that there isn't an order to the planets anymore can probably come up with their own order to use that at least makes some amount of sense. I personally order the moons after their parent planets and the Kuiper Belt objects by a mnemonic. So this has been Vector Graphics, and there are 37 planets in the solar system.